So hi guys, welcome to Insane Techie. Today we would be starting our second lecture, which is find the Fibonacci's number. So one important point here is I will implement it using recursion because it is widely used in an interview because the interviewer wants to know your skill, like how good you are at recursion. So I will tell you how the recursive tree is formed based on this Fibonacci series. So don't miss that part because after that we would be discussing the dynamic programming. So that would be very useful. So before that, I will tell you like what is the Fibonacci series. If suppose we are having a series like 0, 1, okay. So just add these two. So after adding this, we will get 1. So again we will add these two number and what we will get 2. So our current number would be the summation of the previous two number. Okay, so it would be 3. Now again 3 plus 2 it will be 5. 5 plus 3 it would be 8. So now what is so special about this series? It is widely used in our nature right now. Okay, so actually Fibonacci number is not that much famous. Fibonacci spiral is more famous. So what is Fibonacci spiral? So if suppose I will make a square of one block, then another square of dimension 1. If I will create one more square over it, that would be of dimension 1, 1, 2, right? At the left part of this, if I will again fill it with one more square, what I will get? I will get 2 plus 1, 3, right? So below this, if I will draw one more square, what I will get? 3 plus 2, that is 5, right? And at the right, if suppose one more rectangle I will create, so how much it would be? 5 plus 3, 8. So as you can see now, we have got our Fibonacci number series 1, 1, 2, 3, 5, 8. 1, 1, 2, 3, 5, 8, right? So what I will do next is I will just draw the corners, see what we will get. One corner, second corner, second corner, third corner, fourth corner, fifth corner, sixth corner. So as you can see, here is one spiral, right? So this spiral you can see it n number of places. The most famous example is in the petals, you can see the spiral, right? So what was our question? Our question is like, so what is the fifth Fibonacci number? 1, 2, 3, 4, 5. So our output would be 3, right? So now let's jump in directly to the solution part. I will write a pseudocode. So after pseudocode, I will create a recursive tree for that. So don't miss that part because that recursive tree is very helpful to know the dynamic programming concepts. Okay. So let's go to the solution part. So firstly, I will create a function. Okay. So I can write int Fibo and here I can write int n. Okay, so you can write it in any programming language. So it's a generic code. Okay, so the first thing which we have to do here is we have to write the base condition. After base condition, our main logic. So here we have to write the base condition, and here we will write the main logic. Okay, so what would be our base condition? Suppose the value of n is this one. So what is the base condition? Base condition is this one and this. We are having two base conditions here, right? So if n equal to 0 or n equal to 1, return n. Okay, if we have reached at this point, we have to return directly. Okay, so this is our base condition. Now what is our main logic? So our current element would be the sum of the previous two. Same thing we have to do it here. Return Fibo of n minus 1, Fibo of n minus 1 and n minus 2 plus n minus 2. So our pseudocode is ready. I will explain you this pseudocode with the help of a recursive tree. So I will create a recursive tree for this one. Suppose n equal to 5, Fibo of 5. Fibo of 5, it is splitted into Fibo of 4 and Fibo of 3. Now we have to do it recursively. See the power of recursion. So this is our recursive tree. So you can see like what is our leaf node here. Our leaf node was the base condition 0 and 1. So 1, 0. So by looking into the code, you can easily see like it's a clear 2 to the power n time complexity. As you can see like how complex this particular solution is. This solution won't be accepted in any of the platform. What is our next goal now? In the next video, what I will do is I will try to optimize this solution. So from 2 to the power n, I will minimize the time complexity to big O of n, and this solution would be accepted everywhere.